Welcome back. This is section 12.4, all about the conic section hyperbolas. So we're going to start by just kind of defining what a hyperbola is. So you can see from the picture on the left that we have the cross section of what's happening when we cut a cone with it gets cut in two places for a hyperbola. So the definition of a hyperbola is it's the set of all points in a plane such that the absolute value of the difference, so subtracting the distances from two fixed points, is constant. Those two fixed points that we are finding the distance from are called your foci. So if you remember from our ellipse, we know a little bit about what each focus represents. And now we're just talking about the distance from those 2 points to a point along our hyperbola. If we take the absolute value of those differences, then we're going to find all the hyperbola points. So you can kind of see down below the picture there, it shows the absolute value of the distance 2, which is from the closer focus to our point, plus the distance to the further focus is going to be constant, no matter where we have a point on our hyperbola. So it's just the set of all the points that have that equal distance when they're added together. So you can see the picture kind of creates this shape that we're going to explore a little bit more. So here are our hyperbola pictures. And again, there's kind of a lot going on, but we're going to go through and kind of explain what it all represents. So a hyperbola can face basically one of two directions. So it can face horizontally, where those two sides are kind of facing outward on the x-axis, or it can be oriented vertically, where it's pointing up or down. So the equations for each of those, when we look at those options. So if it is horizontally oriented, our equation for a horizontal hyperbola is going to be x minus h squared divided by a squared minus y minus k squared divided by b squared equals. So let's talk a little bit about where some of those things are coming from. So the h and the k, those are going to represent our center. So this center that you see in the middle here, that, no matter which orientation it has, is where the h and the k are coming from. And then our a and our b, we'll talk a little bit about more down below when we get into where those are coming from. So let's do our vertical equation here. So if the hyperbola is oriented vertically, so kind of facing up and down, things just switch a little bit. So now we have y minus k squared over a squared first. And then we're subtracting from that the x minus h squared over b squared. And that equals 1 again. So those are the equations that we write in order to graph a hyperbola. So let's go through and look a little bit more at where some of this stuff is coming from. So I've zoomed out a little bit so we can kind of see everything at once. So the asymptotes, we have these lines called asymptotes. And those asymptotes, the diagonal lines that we're seeing, and we represent asymptotes with dashed lines. So those are the diagonal lines of the associated rectangle of the hyperbola. So you can see in the center of each hyperbola, we create this rectangle that's connecting each vertex and co-vertex together. When we draw the diagonals of those rectangles, we create asymptotes. Remember, asymptotes are lines that our graph will never cross. So you can see how that creates that almost X shape of our curves of the hyperbola. Those are also always going to go through the center. Those asymptotes will always go through the center of our hyperbola. Okay, so to find the equations of those asymptotes, the formulas look like this. So if the hyperbola is going horizontal, then the asymptotes are going to be y equals plus or minus, because there's two of them. So one going in the positive slope direction, one going in the negative slope direction. B divided by A, and again, we'll get into in just a second where B and A are coming from, times the quantity x minus h being the x of the vertex, plus k, the y of the vertex. So when we do that, we generally get steeper lines. So you can kind of see that those asymptotes are going a little steeper than the one in the vertical. And that's because when we do the vertical asymptotes, those lines are going to be plus or minus a over b. So they're going to have a less steep slope. Times the quantity x minus h plus k. So that small flip in the fraction changes the steepness of the lines, which then creates the different pictures depending on which way it's oriented. All right, so the center of our hyperbolas here is the midpoint of the foci. So you can see from the picture where those foci are. When we find the midpoint of them or the middle of them, that creates our center of our hyperbola. All right, so our next key points are the vertices and the co-vertices. So similar to what we were doing in ellipses, vertices are those turning points of the hyperbola. So kind of the corner, if you will, of the curve, even though it's not an actual corner, it's a curve, but it's kind of that center point of where the curve is happening. So those are the turning points of the hyperbola, and to find their distances from the center, we use plus or minus a. So that a that we've been using in all these equations, that is the distance from the center to either vertex. So to highlight that in the picture, we're going from the center to the vertex. That would be, and then in the vertical one, it would be going up and down from the center to the vertex. All right, then we have our co-vertices. So in our co-vertices, remember those we've seen also in the ellipse, but these are a little bit different. So the co-vertices are plus or minus b units from the center to either co-vertex. And we'll talk in a minute about how we're creating that, but that distance either going vertically on a horizontal hyperbola or going horizontally on a vertical hyperbola are going to give you where your co-vertices are. And the distance from that center to the co-vertex is the b value that we've been using in our formulas. All right, and then finally, we have our foci. So these distances are plus or minus c units from the center to either focus. So that distance is going a little bit further past the vertex from the center. So depending on which way it's oriented, changes which way that's looking. All right. Next we have a transverse axis. So when we have a horizontal hyperbola, that transverse axis is also horizontal. So it's going across basically the center vertically. And the length of that is 2 times a. And remember, a is the distance from the center to the vertex. The same thing is true when it's vertically, it just flips. So now our transverse axis is going to be vertical. That means it's going up and down straight through the center of our hyperbola. And its length is also going to be 2a. That transverse axis is going between the two focuses or the foci. All right, and then finally we have what's called a conjugate axis. So that would be going the opposite direction, which means in a horizontal hyperbola, it is a vertical axis. So going up and down, and its length is 2b, which means it is the distance between the two co-vertices. In a vertical hyperbola, that's going to flip, it's going to go horizontal, between the two co-vertices, and that means the distance is 2b. All right, so we are going to use all of that information now in order to start graphing these and figuring out the equations. So we are going to start by looking at a graph, and from that identifying all our key features and then finding the equation of the hyperbola. So when I look at this first one, I can see that it's facing up and down, which means it's vertically oriented. So this is a vertical hyperbola, which remember helps me kind of determine what my equation is going to look like. And then using the picture, I can start to kind of identify my key information. So the center at this one, I can see right in the middle there, that is at 0, 0. My vertices, so remember that's kind of this point on our hyperbola curve. There's one up above and one down below. And just using those coordinates, I can see that it's at 0, 3 and 0 and -3. So those are my vertices, and I'm going to use those to help me. So what I need to do next is I need to kind of construct that rectangle that helps me figure out those asymptotes, which are already drawn on here for me. So what I do is from those vertices, I draw a straight horizontal line through that vertex that connects the two asymptotes. I do that same thing on the bottom. And what I can do then is create that rectangle shape. And that allows me to figure out where my co-vertices are. So now I can see if I go straight out from that center to where that rectangle is now, I have a co-vertice at 4, 0, co-vertice over on the left side at -4, 0. So that rectangle really helps me to create those key points. All right, so based on that, I can now fill in the rest of this. So remember, A is the distance from that center up to a vertex. So that distance in this case is 3. And the B value is the distance from the center to a co-vertex. So I can see that that is 4. All right, and then we can write our two equations that we know. So my asymptote equation for this one, since it is vertically oriented, remember that means that it is y equals plus or minus b over a, so in our case 4/3, times the quantity x minus the h, which is the x of the center, plus k, which is the y of the center. So it would look like that. If we wanted to simplify that, since 0 and 0 aren't going to affect our equation, we could also just write it as plus or minus 4/3 x. So those are lines that start at 0, 0. One's going up 4/3, the other one's going down 4/3. Create those two asymptotes. All right, and then we can also write our equation of our hyperbola now. So since it is vertically oriented, that means that we start with our y's. So I would do y minus the h, but remember h is 0, so I'm just going to leave it as y squared over our b value squared. So that would be 4 squared minus x, and then again minus h, but our h value is 0, so I'm just going to leave it as x squared over a squared equals 1. When I simplify that, I'm going to get y squared over 16 minus x squared over 9 equals 1. That's my final equation of my hyperbola. All right, let's try one more. So this time in example 2, when I look at my graph, I can see that this one is horizontally oriented. It's facing the left and the right, or the x-axis is more where it's oriented. So that helps me there. Then I can use my picture to identify my center here. The coordinates of that center are -3 and 2. And then that allows me to start finding my vertices. So I can see I've got one vertex on the left side and one vertex on the right side. Those both labeled. So those vertices are at -6, 2, and 0, 2. All right, so I'm going to use what we talked about earlier to start making that rectangle to kind of help me. So this rectangle, if I draw my line, goes straight up and down from each vertex to where it intersects the asymptote. So let's get those lines in there. And then we connect them to make our rectangle. So now I can see that my co-vertices are going to be in the middle of those sides that I just created. So the coordinates of those are going to be at -3, 7, and -3, -3. All right, so then I know, looking at those distances again to find A and B, the distance from the center to a vertex in this case is 3. And the distance from the center to a co-vertex in this case is 5. So to find our asymptote equation on this one, it's going to be y equals plus or minus. Since it is horizontal for this hyperbola, the equation is going to be b over a times x minus the h, which in this case is -3, so it'd be minus a -3. So I'm going to make that plus 3. And then plus 2. And as I do that one, I notice that in my problem up above, we did our asymptote backwards. So this one up above, since it was a vertical asymptote, it should have been a over b. So this asymptote up here should have been 3/4 instead of 4/3. Sorry about that. Okay, so getting back to example 2 here. Let's finish off our equation of our hyperbola. So our hyperbola in this case, since it's horizontal, is going to go y equals x minus h. Again, that h is -3, so I'm going to write it as plus 3 squared over the a squared. So that's going to be 9. Y minus the k value, which is 2 squared, over b squared. So b squared is 25, because 5 squared is 25, and that equals 1. So that would be our equation of our hyperbola. All right, so last thing we're going to do here is we are going to look at an equation and figure out its graph. So let's look at our first example here. All right, so we have the equation x squared over 25 minus y squared over 49 equals 1. So based on what I am seeing here, since it starts with an x squared in our equation, that means that this is going to be horizontally oriented. So since we've got an x squared to start, that's a horizontal orientation. So that helps me to kind of start figuring things out. Based on that equation, again, from those things attached to the x and the y, since there's nothing there, that tells me that my center is at 0, 0. And then using my a and b, which we figured out in this equation, 25, I'm going to use that to help me here. So that 25 is going to help me figure out where my vertices are. So since it's 25, that tells me that our a is 5, and that means my vertices are 5 away from the center. So that means that they are at -5, 0 and 5, 0. And then using that same idea, but now with the b value, if b squared is 49, that means b is 7. So that means my co-vertices are 7 away from the center. So that means they are at 0, 7 and 0, -7. And then lastly, we can find our foci. So remember that equation, c squared equals a squared, which we know is 5, plus b squared, b is 7. When I add those together, 5 squared is 25, 7 squared is 49, so that's going to give me 74. And then when I simplify that, I get that c is about, the square root of 74 is not exact, so c is about plus or minus 8.6. So that means my foci are plus and minus 8.6 away from the center. That tells me, since this one is horizontally oriented, that the coordinates of those would be 8.6, 0 and -8.6, 0. All right, and then lastly, I can do my asymptote equations. So in a horizontal, my asymptotes are going to be y equals plus or minus the b value, which is 7, over the a value, times x minus our h, but remember our h is 0 and our k is 0, so I don't need to add anything else to that. If they were any other number, we need to continue with that. But since they're 0, we can be done there. All right, so knowing all of that, I can now graph all of that and see that the graph of my hyperbola would look like this. So you can see where the foci are, you can see where the vertices are, you can see where that center is, and you can see what it would look like. All right, let's look at one more example here. So in this example, I can see up here in my equation that, first of all, my equation starts with y minus 3, and that tells me that this is a vertically oriented hyperbola. And I can also use those values to identify my center. So my center here, looking at the number attached to x, it says plus 2, so remember that's a minus 2 because the formula is x minus, so that would be x minus a negative 2. And then the number attached to the y, that's a 3, so my center, therefore, is at negative 2, 3. So I could plot that on my graph. And then I can start using my key information here. So to find my vertices, I'm going to use that 4. So that 4 tells me that my A distance is going to be 2, because the square root of 4 is 2. And that means, since it's vertically oriented, that my vertices are 2 away from the center in the y direction. So that tells me that they're at negative 2, 5, and negative 2, 1. I also know from this equation up here that 9 is going to help me find my b distance. So the b distance would be 3. That means my co-vertices are 3 away from the center. So that would put them at negative 5, 3, and 1, 3. All right, and then our last two things are to find those foci and the asymptote equations. So my foci I can find by doing c squared equals a squared, which we know is 4, plus b squared, which is 9. That equals 13. So when I take the square root of that, I get that c is about, again, the square root of 13 is not exact, so it's about 3.6. So that means that my foci are 3.6 above and below my center, based on the fact that this is a vertical orientation. All right, lastly, we're going to do our asymptote equation. So our asymptote in this equation is y equals plus or minus, and then since this is vertical, it's a over b times the quantity x minus h, which is again our center, so that would be minus a negative 2, so I'm going to write it as plus, and then plus the k value, which is 3. So knowing all of that, I can put together my whole picture here with my center at negative 2, 3, my vertices, my co-vertices, and my foci. All right, that is all about hyperbolas. We'll see you next time.